So today is a fairly easy step. Today is the foundation for the rest of our week, okay? Today we're talking about understanding error and defining residuals. So the paper that you picked up, it should have been a front and back paper with some tables and graphs on it. And we're going to be working through this worksheet. Capisce? All right. It's actually capisco or capasco, which means I understand in Italian. But a lot of people just say capiche, capash, which we just made up in America. But that's not what it is. Yeah. So say. All right, here we go. Residual means. So our first blank on our notes, it says residual means. Read it with me. What does it say in the quotes? Actual y minus expected y. That is what you're putting. Your residual means it's your actual y minus your expected y. Okay? We're calculating our error. So if you look right here on the graph that's on your notes, you have, and I know it says red, but your paper doesn't print in color, so yours isn't red. But you can always go over it with a red pen or marker, right? So the diamonds represent our scatter plot points. So the diamond, this is our original information. So this is our original. Okay. The regression points, this is what we get after we do our lin reg in the calculator. Okay. That's what we get after doing lin reg. The red line segments, these segments, they're called our residual lines. Okay. What they're telling us is what's the distance between the y values and the x values. Okay. How far apart am I away from those values? All right. Huh? Our linear regression, our ln reg in our calculator. Okay, so the length, that's called our, oops, I didn't mean to cross it out, our residual. So what we're doing today is we're going to practice calculating the residual by hand. Okay. So if I'm calculating the residual, what math operation am I doing in order to find the distance? We're going to be doing some subtracting, hence why it says your actual minus your expected. Okay. Do you think you're fully capable of subtracting? I think you are too. I believe in you. All right. So that's what we're going to be doing. We're going to be calculating our residual of a given data. Got it? And that's our error. How far appropriate is it, or is it exact, or is it not? But we're looking for our error. Okay. Are you ready? The other thing I want to point out is because it says distance, even though we get a negative number, can you have a negative distance? No. If you walk backwards, guess what? You didn't walk -3 miles. You're just a person who chose to walk 3 miles backwards. Okay. All right. So there isn't a negative distance. The distance is going to be the distance. Got it? All right. Okay. Here we go. So we're going to finding the residual. We have 3 people, Stella, Jasmine, and Brandy. They went on a road trip. Every so often, someone wrote down how long they had traveled in minutes and how far they had traveled in miles. Each person later created a scatter plot in their own equation to represent the data. Okay. So looking at what we have, what represents our independent variable? Time. Time is our independent variable. So we're going to call that X, right? Okay. And therefore our dependent variable is the Y, the distance, right? So we're looking at how far we traveled given a certain amount of time. Make sense?
Yes, ma'am.
All right. So it's our distance per our time. In this case, it's our miles per hour minute. Not hour. It's our miles over hour minutes. Okay. All right. So this is our data that we're going to be using. You're going to be using this table today and tomorrow. Got it? Okay. So we have here's Stella's equation. So Stella said, I think the best equation to model what we just did on our road trip is y equals 1 in 400x plus 3 in 4600ths. So that's her model. She drew her line and she plotted the points. Now, isn't it pretty hard to be able to measure our residual lines from here? Yes, so this is a visual, but we cannot actually calculate the residuals, okay? We're gonna have to figure it out ourselves. Our actual values are given to us. We're going to calculate our expected Y using the equation that Stella thinks best fits the data, okay? So we're using this to find the Y, and your X values are never going to change because aren't they all traveling together for the same amount of time? Yeah. So why would their time change? It wouldn't, right? So their X values are going to all stay the same. So there are a couple ways that we talked about how to fill in a table. So we're going to open our handy dandy calculator. I'm going to open good old faithful here. I'm going to clear by pressing second plus 712. Second plus 712. Okay, good. Second plus 712. All right. Now that I've cleared, option number one of anytime figuring out the value of something given the X value is to just plug it in, right? I can simply just plug in 1 400 times 30 plus 3 46. Is that doable? Yeah. All I did was plug in my X value into my equation. Wait, how come we did 30 and 50? Because that's my X. It says 1 400 times X plus 3 4600. And I hit enter, and what do I get as the value? So my expected value from here is 34.66. Okay, that is option one of plugging in. That is the way that you've learned before. When given the X, you plug it in, right? Okay, now we're going to talk about working smarter and not harder. Yes. Why is the actual one? Because this is the one that she created with her. This is her expected. This is what Stella is saying. This is the best graph for our data. This is your actual, like as they travel, this is the actual distance they went. This is our expected. She estimated a graph to model it. Okay. That's what we're figuring. No, it's not going to be exact because you're trying to find one that's going to fit most of your data, your actual data. Because in the real world, is everything perfectly linear? No, the linear is just used to help us make predictions, but nothing in our life is perfectly linear. Does that make sense? Okay, you're not going to always be driving the same speed on a highway, right? Sometimes you slow down, sometimes you brake real hard, but you're not. I mean, you could be on cruise control, but you're going to be on cruise control the entire time? No, you're not. All right, so that's option number one. Now, could I do this for all of my X values and be done? Yes. But remember, I said we're going to think smarter, not harder. Okay. So we're going to go to Y equals. Why am I going to go to Y equals? Because she gave me an equation. So I'm going to write my equation. So I'm going to write 1 400 X plus 3 4600. Guys, extra talking interferes with other people learning. All right. So now that I have this in, if I'm looking for a value, we talked about there's a couple of ways of doing it using the equation, right? Way number one is I can go to the graph, and from the graph, I can hit second trace and type in the values that I need. Okay. Because you did not put it in correctly. Okay. Okay. All we did was graph. We haven't did anything else but type Y equals. Not sure what you did or why you didn't do it. But all we did was do Y equals. We went to Y equals and then we pressed graph because an equation leads to a graph. And that's it. Alpha and your variable key is right next to your, or alpha or X, or your variable key is right next to alpha, which means you don't have to hit alpha. You just use the variable key. So I can just press X and it'll put in the correct variable. Okay. So again, all I did was go to graph. So I have an equation, it leads to a graph. Okay. A lot of math is using a little bit of common sense and finding the pattern. Okay. If you have an equation, it takes you to a graph. All right. From here, I can hit second trace and I'm looking for specific values, right? So you see where it says value? Yes. I'm going to click on value and I can type in what I'm looking for. So if I'm looking for 30, I can hit enter and it's going to be like, oh no, you don't see 30. I'm like, ah, dang it. It's broken. I'm quitting because I can't do this. Because that's what you guys do every single time, Gen Z. Okay. No, you don't quit. It just means that there's an issue. The issue is that the values that you want do not fit your window. Does that make sense? Okay. That means that the values that I want do not fit my window. So I need to go to it and change my window. So if I want bigger X values, I'm going to have to make it where I have bigger X values. Does that make sense? So if I need bigger X values, how high do my X values go? 185. So I'm going to put in 200. That should cover it. On the X. Oh, no, I want. Okay. And I'm going to count by, I'm going to count by 25. So I just don't want a bunch of little tick marks everywhere. My Y min, clearly it could be higher than 0. But looking at what my actual Y's were, doesn't it need to be higher than 10? Yeah. Yes, it's at 190. So doesn't it need to be higher than 10? Yeah. So if I put 200 here as well. And again, you can count by whatever you want. I'm just going to put in 25. So when I got that error, that let me know that the graph I had, I could not see the value I was looking for. Does that make sense? It does not necessarily mean I did something wrong. My window needed to be adjusted. So now I go to graph and I'm going to try it again. All right, second trace. I'm going to show you who's the boss. So I type in 30 and I hit enter and it says, oh, I got you. It's 34.66. Okay. And I'm going to type in 62 and it says, oh, I got you. It's 67.94. Okay, so let's talk about how your table did. Did everyone at your table was able to use the graph to find the values? Okay, so again, remember, it's second trace was what we did here, right? So with the graph, it's second trace, and then we type in value, and we're finding the value. So 85 gave me 91.86. 124 gave me 132.42. Uh-oh. 151 gave me 160.5, and 185 gave me. Okay, doable. Okay, now we're going to calculate the residual, the error. How far apart are these? Okay, to calculate the error, you're going to go back to your calculator page. This is if you're not strong at mentally subtracting, which is A-okay, okay? To get back to our calculator page, we press second mode. Okay, so we're going to press second mode. Okay, and now we're going to calculate residual. Residual is your actual minus your expected equals your difference. That's why I said, if you're good at mental math, you can subtract. So we have 30 minus 34 0.66 equals, and that's negative 4.66. Agreed? Okay, now we're gonna do the next one. So our actual minus our expected. 65 minus 67 and 9400 equals negative 2 and 9400, right? All right, 102 minus 91 and 8600. There we go. 130 minus 132 and 4200.
2.42. Oh, negative.
It's going to be a negative because my first number is smaller, right?
Oh, I see it now.
What is 165 minus 160.5?
1.5.
And last but not least, 190. Uh-oh, that's an equal sign. My bad. 190 minus 195 and 8600. Okay. Could we have looked at the graph and seen that's what our residual lines are? No, look at this. You could tell me that this is 5, this is blah, 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 just by looking. No, we had to calculate the error, okay? So looking at what we have, thinking about distance, which one is the shortest distance? Which two are the shortest distance from our actual line? It should have been 62 and 124, okay? Remember, distance, do we care that it's negative? No. Okay. I said, which are the shortest two? Yeah.
Oh, you said
Yeah.
other.
Yeah. Shortest two. So it would be 162 and 124. How do you feel about calculating the residual? This is the foundation of this week. So if you have questions about calculating the residual, ask me. Okay. Okay. So I'm glad you're wondering when are you going to do it. Here we go. So we're going to go through it again with Jasmine. Okay, we're going to do it again for homegirl Jasmine. All right, for homegirl Jasmine, I'm going to show you another way. And then when we get to the last one, you choose your poison. Got it? All right, so the first way we did it was with the graph. Guess what we're going to do this time? We already did a graph. We're going to use a table. We're going to use a table feature, okay? All right, so I'm going to go to y equals. And this time, what is Jasmine's equation? 1.09x. Show a neighbor that you have put this equation in before we go on. So show a neighbor that you have put in y equals 1.09x minus 2.81. Neighbor, if they have not. Okay. Are you going to be watching the videos to learn how to do this since you're not following along? Oh, okay. All right. All right. Are we good? Here we go. So now this time you're going to be using our table setting. Okay. So this is our example with table. So for table settings, we're going to be using our table set. And to use the table set, we're going to press second window. Yes. All right, so go to second window. Here we go. So to get to the table, so we are press second window. You see where it says ask for independent? We want to switch to ask. So we want to switch to ask. So what do? We went second window, and we're switching our independent to what? Ask. Independent is our what variable? X. We want to be able to put in our own X values. Does that make sense? All right. After we do that, we're now going to go to the table. So we go to second graph to open our table. Do you notice that our table is blank? That's because we're going to put in the values that we want. We only want 30. Bam. We only want 62. Second graph. Second graph. Same buttons we've been doing. So we have 30, 62, 85, 124, 151, and 185. You gotta learn the other ways to be more appreciative. You know? You know what I'm saying? No, you're gonna keep it. Okay? All right. So we went through the three different ways. We have the old school way of the calculator page. We have the graph where we control second trace. And then we have our table set where we actually create our table in the calculator. Okay? So you have the one you're gonna choose when we come in tomorrow. You're gonna choose which one you want to do to complete the two graph. Okay? All right.